Hey guys, Mr. Marone here. Welcome back in. Apologize if the sound is a little bit wonky. I don't have my microphone here at home. So we are going to be taking a look at lesson 5.4 today, which is inequalities in a single triangle. And as you can tell by the name, inequalities, that means we're going to have um, a comparison where almost all of our answers are going to have more than one answer. We're going to have x is greater than a whole combination, an infinite number of answers and things like that. So our main concept here is if we look at these triangles, this first one they gave us a right triangle, and that tells me that the other two angles are going to be smaller than 90 degrees in order for us to be able to have a right triangle. And if we look closely, the largest angle here, our right angle, happens to be across from the longest side. So our largest angle and our longest side are in a comparison here. Now, if we look closely at this other triangle, this appears to be an obtuse angle here, bigger than 90, and that's once again across from our longest side. So the relationship you have here is that the largest angle is always going to be across from the longest side measure. You can always tell where one is given the other. So if we look closely at this, um, it appears that angle M is our largest angle, and it kind of works out because it's across from our longest side. But if you look closely at the picture, this angle N is our smallest angle by far. It's smaller than P, and it happens to be straight across from our shortest side of the three given. So that gives us a relationship that we can use as well, and that's the smallest angle is across from the shortest side. And so what this allows us to do is label our triangle and identify our triangle based off of its measures. So if we look at this example here, I'm going to switch colors so we can actually see what I'm writing. It says to support a triangular piece of a float, a brace is placed at the largest angle and a guide wire is placed at the smallest angle. And they want to know which is the largest and which is the smallest. They gave us the side lengths. We can use those side lengths to identify where the smallest, the middle, and the largest angles are. So if we look closely, our shortest side is this 10-foot side. So that's going to be straight across from angle B. So in other words, if we list our sides, 10 feet, 12 feet, 13 feet, our smallest, medium, and largest angle are going to follow that suit. So straight across from 10 is angle B. Straight across from 12 is angle A. And then straight across from 13 is angle C. So if we're looking at our question here, it says which angle is the largest? Well, angle C is the largest because it's across from our largest side. And if we're looking for the smallest, that would be angle B. So they would want to put the brace at angle C and the guide wire at angle B. So we can use this same idea in a bunch of different ways, and that's where this triangle inequality theorem that you're seeing on your screen comes from. So if I look closely at this given triangle here, they gave us 62 degrees and 50 degrees. We can find out what angle K is using triangle sum. So we can do 62 plus 50, which should give you 112. And if I do 180 minus 112, I get 68 degrees. So that tells me that K is my largest angle. So if I'm ranking these from smallest to largest, I have angle L, I have angle M, and then I have angle K. And if we use that to figure out our side lengths, straight across from our smallest angle is our shortest side. That's side KM. Straight across from angle M is our next one, so that's side KL. And then straight across from angle K is side LM. If you look at this, notice that all three vertices of my triangle are used at each one. So the quick way to do it, even if you don't have a picture, is to use the angle labels and then use the other two vertices that have not been used yet. So if angle L was used, well, KM has to be across from it, and so on and so forth. And that leads us to this main other concept here, which is called the triangle inequality theorem. And it tells you that in order for you to have a triangle, any two sides of the triangle have to add up to more than the third side. And this is just kind of an easy one to look at. If you picked 3 items and this didn't work, you couldn't build a triangle. So if we look at this set 1 here, if we added 19 and 18, we'd get 37. 37 is less than 40 inches. So basically, if I were to lay my 19-inch side here and my 18-inch side here, that's what my picture would look like. I couldn't get a triangle because they won't lean against each other. If we looked at the second example, 33 plus 37 is going to give you 70. And 70 is larger than 66. So that would allow me to lean them against each other, almost like if you're building a fort. And that leads us to our final piece here, is they want to know what are the possible side lengths of this third side. This is where inequalities come in because it can be a bunch of different things. The way you're going to do this is, let's assume that this is the longest side. So that tells me that I have to do 11 plus 16, and those together have to be bigger than x. If we solve that, we'd end up with 27 greater than x. So x has to be less than 27. If we then use x as our smallest side, that would mean x plus 11 has to be bigger than 16. And if I do just a little bit of algebra here, x has to be greater than 5. So that tells me anything bigger than 5, anything less than 27, and I'm going to have a triangle. If we went less than 5, they wouldn't be able to build a triangle. If we went greater than 27, same thing would happen. If you guys have any questions, be sure to bring them into class, and I will see you guys tomorrow.